Hello, everyone, and welcome. Whether you're a returning visitor or new to our platform, we're thrilled to have you with us. I am Michael Anthony Suarez, the Marketing and Communications Specialist for Smart Cities Connect, a brand of Tech Connect. Today, we have an amazing expert, Tyson Eckentile, ready to share his insights about the vast data generated by Internet of Things, also known as IoT. Tyson is the Global Manager for IoT Partner and Business Development within the IoT division at SAS. He works with SAS partners to explore the vast data generated by the Internet of Things and collaborates with partners to build and deploy IoT solutions that solve real-life problems across a wide variety of industries, including government, agricultural, energy and utilities, and also HLS. Hi, Tyson. Welcome.
Hey, Michael, how are you? Thank you for having me today.
I'm good. Thank you. Thank you for being here today. I want to start off by kicking it off. If you can explain a little bit more about your role at SAS within the IoT division, please.
Absolutely. So within the IoT division at SAS, I manage a team of business development executives, and our core charter is to work with industry partners and overall ecosystems to solve some of the world's most difficult challenges. What we do is we integrate our technologies because if you know a little bit about the Internet of Things, it's a vast ecosystem, often known as the maze of complexity. And so we work together, bringing our industry core competencies, subject matter expertise, and technologies to collaborate and integrate to solve some of these challenges around the globe. Again, in those industries that you had mentioned earlier, in which today we'll talk a little bit about the public sector and how we're working together to solve some of those global challenges.
Awesome. Great. Thank you. Can you provide any recent examples of how you've partnered with an ecosystem to tackle a significant challenge within the public sector?
Absolutely. So a couple of years ago, at the onset of our partnership with Microsoft, we looked at some of these challenges across the globe, and one that stuck out significantly was flooding. And so flooding is the most frequent natural disaster across the globe. It has no boundaries. It affects communities of all shapes and sizes and economic status. And so we wanted to take a look at that and figure out how can we complement some of the traditional practices that focused on engineering principles, such as hydraulic and hydrological modeling, introduce a new set of technologies such as the use of sensor technologies to give us new data and insights, all the way through AI and machine learning algorithms, and then the implementation of a digital twin. And so what's unique about that is that when you look at an edge to cloud solution, SAS is an analytics company, right? And we want to stay core to who our true identity is. But we can't run analytics without data, right? There's the old saying of garbage in, garbage out. So we need to ensure that we get quality data, and we need to fill in some of those blind spots. But there's a lot of integrations of technologies across that edge to cloud architecture. So we need to engage some of our core partners. And in this case, we started to work with Microsoft. And then further down that road, it was sensor technology companies. It was folks like Intel that we'll talk about here a little later, and how we can create this truly robust, scalable, interoperable solution that solves a challenge such as flooding. So that's one that we will talk about here throughout this conversation, but that was a recent example. And when we looked at that problem, we weren't going to just jump right in and say, hey, we can solve this. It's going to take years of research and development, tweaking those models, getting access to that data, and understanding the true issue at hand, working with the end clients or that community of public stakeholders, whether it's a municipality, a county, a state, an entire country, also looking at the engineering community and what are some of the gaps in their ways and methodologies of tackling this significant challenge, and coming together with the technologist and bringing this in-house at SAS was looking at how do we stay in our swim lane, but also engage our partners to solve such a tall task around the globe.
Very interesting. Okay, very good. What are some of your competitive differentiators for this solution or SaaS technology in general?
That's a great question. And so maybe I'll start with some of the differentiators that SAS brings to the table within the IoT division. So first and foremost, we can process data in real time at a high rate of speed. We have this as part of our analytics for IoT product, as well as if you look outside of analytics for IoT and the IoT offering, what is known as SAS VIA. If we were to apply that to, say, our flood prediction and preparedness solution, we essentially create this massive data abstraction layer, right? So the more data that SAS can analyze, the better, right? That's where we get a more efficient and accurate result. When it comes to flood prediction, we essentially can crunch all of this data in less than half a second and visualize that in a forecasted urban inundation model. And so traditionally, it would take groups of engineers days, if not weeks, to run this analysis from an inundation perspective. The back end of SAS, which is highly complex and can provide a very quick analysis, can do this in less than a second. In addition to that competitive differentiator, from a technology perspective specific to SAS, our approach to a solution such as flooding is also unique and offers a competitive differentiator. So what we do from a high level is we create a digital twin of the environment. And I know that that's a buzzword in the industry, but what we really do is we visualize digitally the environment, and then we also analyze and visualize the water process, right, throughout that environment. And so our approach is looking at it from, we're going to leverage our best practices of an analytics company, but then also cultivating and incubating that ecosystem to create a differentiator around the approach in terms of a digital twin. However, we still build upon and leverage the traditional methods and practices that are put into place around engineering, right? So we still use those engineering models. We still use weather forecasts, right? Those are all essential components. But then we filter in real-time data from sensor technologies. We create the digitized environment to create this digital twin that is dynamic in nature, right? So you can manipulate that digital twin, and it also provides an advanced analysis of water within that environment and displays that in a meaningful way. So we truly have that actionable insight. When it comes to flooding, real time isn't good enough, right? We don't want to know that we're standing in 3 feet of water when we're standing in 3 feet of water. We don't want to evacuate, citizens via a route that is inundated and unsafe to travel. We want to anticipate where that high level of inundation is going to be to protect citizens and also protect, critical assets and infrastructure. So we need to be predictive in nature and anticipate where that water flow is going to be.
Excellent. Okay, this is also fascinating, especially because I went, this past conference, we were there, we were in your building. It's amazing. And I guess some of like a question that I have is, you're talking about the efficiencies, right? You're talking about the processes. Are you able to provide like this real-time data, these analytics, all this sort of thing to communities that need it? For example, the water, if there's a water challenge, is that because you guys have been doing this for a really long time, so you've figured out like ways to be able to identify that? Or is it because you guys just have tremendous resources and a big team to be able to provide that? Or both?
Yeah, so we've been working on this for about 4.5, going on 5 years. SAS is an organization, a company that likes to invest from an R&D perspective, right? Really understand the challenge and task at hand, and a methodical approach to solving that equation. And from our perspective, it's a model, right? How do we create a model that provides a result that's highly effective? Now, when we do that, we have to almost reverse engineer the problem. What are the data requirements we need to populate this analytical model? At what frequency do we need the data? And when you go down to that data abstraction layer, what is the uptime of, say, the hardware that's providing us that data? So we understood that when we're creating this edge to cloud solution, right, there are components that are outside of SAS's core competency and offering, right? We're software, we're analytics. So we expanded out to our partners. Microsoft and Intel are two examples of those partners. Microsoft brings a robust cloud infrastructure where we can host and manage this solution, do all of our cloud computing and visualization. Intel is a multifaceted partner that powers the edge with their chipsets, but also all the way up into their cloud from a CPU and VM perspective. What we then looked at is, okay, so we have two strategic core partners that provide scale, they provide security measures, but they also provide this flexible dynamic environment that can be open-ended towards how we bring that data in. There's a rather robust source of historical data that's important for creating these models. There's publicly available data through other entities, whether if we're sticking to flooding, USGS here in the United States, NOAA. There's a lot of information from a municipal, all the way county, statewide, from a data layer. But then it's also that real-time information that provides ground truth data sets that we need to analyze that specific environment. And so what we looked at is, how can SAS pull on that ecosystem that we have cultivated over the years to provide access to that data? And that data can be things like surface water level. It can be things like what is the flow rates inside of a river, a creek, or even in a stormwater system, rain gauges, localized weather stations. And so we have this approach where we want to do a robust data assessment and understand historically, how does this environment respond to flooding from historical events, and then understand what are some of those data gaps we have. Yes, SAS can help identify those data gaps, but we have to rely and lean on our ecosystem to provide that actual physical asset to give us the data in those areas. And then of course, it truly does take a village to provide these insights for such a complex challenge. And so that's the way that SAS really has approached this, and that's the core function of our IoT practice. How do we work with industry partners to solve these challenges collectively, with keeping in mind a couple of core methodologies of how do we create a blueprint for future solutions? How do we handle changing requirements, whether it's technical requirements or business requirements, right? So we want to future-proof that approach as well.
Awesome. Tyson, you made some really great points, and that's really fascinating. And I'm glad to hear that there's a lot of collaboration happening within the ecosystem, because most often than not, I think it's good to be able to work with other industry folks or other city leaders. And that's been a big conversation at our conferences, right, about collaboration and how to leverage data and that sort of thing. So it's good to know that an organization like yourself, like the one that you are at, is also doing things like that. Earlier, you also talked a little bit about digital twins and how it is a buzzword, and there's a lot of that happening across different industries or different sectors. So how does that benefit government? Specifically with what you all are doing?
Yeah, it's a great question. And, when I think of a digital twin, if I were to, define it in simplest terms, it's a digital or a virtual representation of an object, an environment, and or a process. And so if I were to take the digital twin concept and apply it to flooding or even transportation, the first thing we need to do is we need to create that digital or virtual profile of that environment. So when we look at a geographic region, such as a municipality or a county or even a segment of a municipality, we look at it from a geospatial perspective, right? What is the digital elevation map that we can integrate with? That's the elevations and undulations. And then all the different components around that environment. So if we really focus on flooding, we want to also understand soil type and infiltration rates. We want to understand where those impervious surfaces are, what the land cover is, because that land cover also impacts overall flows of water, right? Is it a land cover that's been impacted by a burn scar where you have greater runoff and debris and sediment that can essentially wash away? Or is it a thick vegetation land cover that can essentially absorb and slow down that water? In addition to that, we want to understand what are the different waterways that are in that environment, right? Whether that waterway is a creek, a river, a lake, a dam, an ocean, or the waterway also is a stormwater system. And that stormwater system has a design and a capacity, right? What's the pipe diameter? Are there friction coefficients from that's impacting the water in which the rate it moves through that overall stormwater system? So all of that is data that goes into the virtual or digital representation of that environment. And then we look at the process. It's the process of water within that environment, right? So water can be from a river, it can be from ice melt, it can be from precipitation. And so we need to understand, how do we get a better understanding of the amount of water? So that's where you want to incorporate some of those dynamic data elements, right? So you have forecasting systems, you have localized weather stations, you have rain gauges for intensity and propensity over time. You also have things like looking at flow rate inside of the rivers or the creeks. You have surface water levels, so it can be LiDAR or other sensing technologies. And what we're really creating is this robust data abstraction layer of that environment and the process of water within that environment. And then you start to fold in that advanced analytics of saying, how do you use machine learning and AI to couple with that digital representation? And then we analyze and we predict. So this is also important, right? In the industry, we look at things like pastcast, right? So that's simulation, the historical analysis of historical events within that environment. They call it nowcast, what's happening in real time now. And then you have your future cast, right? What do we predict is going to happen? And so an easy concept to pull from are things like Doppler radar, right? We're looking at size, intensity, direction of a weather system moving across a geographic region. How do we create that same approach for, say, flood inundation? And where the pastcast is important because we want to understand the context historically and understand that environment. The nowcast is great, but again, we need more than real-time analysis of flooding because we need to have a time to take action, hence actionable insight. So we need to introduce advanced analytics through machine learning and AI to provide that future look into flooding into that digital twin environment. And then ultimately you visualize that in a meaningful way. And it doesn't have to be three-dimensional where we can see 4 inches of water on a roadway. If the model is telling you that there's 4 inches there, there's no problem looking at that two-dimensionally or even through a dynamic report that's indicating that. So ultimately, when we really look at digital twins, it's this robust data abstraction layer where we're just visualizing and digitizing that environment. And then what is it that we want to observe within that environment, right? If you look at a manufacturing setting, it might be a specific piece of equipment. And we can look at that from a digital twin perspective, but what are we analyzing? Maybe it's a very specific component of a motor, and we want to look at vibration analysis, and you want to factor in other things like temperature, right? And with that vibration, and do advanced fault detection, right? So we want to predict when it will have a fault, so we don't get to that point where you have that break fix model. Instead, we proactively service that piece of equipment to maintain the uptime.
Right. Okay. So I know, just a quick follow up there. So I know you're talking about like flood, as for example, for this conversation, but can you apply that or the same principles and the same tactics to something else?
Yeah, absolutely. So we had talked a little bit earlier around when you're making decisions on the integrations of technology from edge to cloud, or it might even be edge, right? You can process in certain use cases at the edge. We want to ensure that we have scalable and secure technologies that serve multi-purpose or multi-use. So the Mesa complexity is, in my opinion, the true edge to cloud architecture of an IoT solution. And when you bring in technologies that are interoperable, scalable, extensible, flexible, you can use those as a blueprint for additional use cases. So we are actually using this blueprint that we've put together with a Microsoft and an Intel in different, we'll call it networks, whether it's cellular or LoRaWAN. You can swap out the data that we need, and you can create the same digital twin for different use cases. So 2 other solutions that we're using, one directly related to flood and disaster mitigation, and one that is using that blueprint for a completely new initiative, is we're looking at fire. So advanced fire detection and analysis, where it's going to spread. Again, we're just simply changing out the data that we're analyzing. So instead of water, we're now looking at things specific to fire, still environmental monitoring. And then we also look at things that are non-environmental from a disaster mitigation perspective, such as transportation. So you still can create a digital twin of the transport infrastructure within a municipality and then fold in real-time data. And in this case, real-time data can be a myriad of things. It can be pedestrians, on and around that infrastructure. It could be the cars, right, that are parked, that are in transit. It can be the traffic signals. It could be the taxi and the bus routes and optimizations. It could be time of year, right? So I live down here in Florida. So time of year depends on things like that impact traffic. So of course we are a big destination for spring breaks and other travel destinations. It can be the hotel chains and what's their capacity. If there's a marina, what is the number of boats that are in the area? What are the events that are taking place locally, whether it's a concert, a sporting event? So again, you're just creating this massive data abstraction layer, and you're analyzing that and visualizing it over the digital twin to understand how to optimize traffic, congestion, mobility of citizens within that environment.
So fascinating. Awesome. Thank you for sharing that. As we shift the conversation just a little bit about partners, right? So like, what do your partners play like in the overall development? I'm curious to also kind of know like, who is your ideal partner that you work with? Since you're in business development, is it more like city leaders? Is it industry folks? Is it innovators? What can you talk a little bit more about how they play a role in the development, but also maybe who the ideal person is that you all
Yeah, absolutely. And it's all the above. When we look at a problem, uh, the first thing to understand is, let's say we're working with an end client that's a government. I always advise that, work with your internal stakeholders across departments and define a very concise and clear problem statement. What are you trying to solve for specifically? And there's subcomponents to that takes into consideration your internal, and in some cases your external. In that regard, it might be the citizens, stakeholders. And then we look at it and say, okay, how would we conceptually solve for this challenge? And so the end client might have some core partners that they work with. SAS certainly has a rather robust ecosystem of partners that we work with. But we look at it and we say, what's important is that we stay within our swim lanes and core competencies. For SAS to go and say, we're going to go and bring hardware to the table from a sensor perspective, that's not our core business, right? And so we want to make sure that as we're looking at how we solve this challenge, it's factoring in all that criteria. But while we're creating the approach to solving that, it's keeping in mind that we don't want to set up future challenges. And just a simple challenge to take into consideration is, we've always talked about data silos, and that data can reside in siloed spots, right? But just because you're digitizing that and you're using advanced technologies doesn't mean that we can't set up yet another data silo. And in this case, it might be a virtual data silo, or it might be a solution that is relatively closed and it can't integrate with other solutions, right? As a true system of systems approach. And so you want to make sure, again, that when we're tackling that specific challenge that's defined very well through the problem statement, that we're bringing in technology components and subject matter expertise that is open and flexible. So when SAS looks at those partners, it's ensuring that we're tackling the challenge at hand, but doing so in a way that allows us to pivot and tackle other challenges in the future as those requirements, whether it's business or technical, change. But we're very much open to all types of companies, right? We've worked with startups that provide us a data point that maybe didn't exist. We look at it from big enterprise companies. I mentioned Intel and Microsoft. We sponsor research institutions. So SAS is very big on research and development. And then I think first and foremost is always keeping the end client at the top item, right? We want to make sure that we are delivering a solution that meets their specific challenges and continues to meet their needs moving forward.
Thank you. So my last question for you is, if you have any advice, what would you give to the community when it comes to implementing these projects, right? Because I think sometimes like they sound so great, and I think we get excited, and the community gets excited. But what advice would you give about the implementation process of it all?
Yeah, there's many different things that I could offer as advice. But one thing that I'll start with is the role of technologists in companies such as SAS. Our job is to make the integration, implementation, and overall interaction with our software as user friendly as possible. In addition to that, it's also our role to work and cultivate an ecosystem that can come together and solve your specific challenge. Municipalities or end clients should not feel that they have to go at this alone, and they have to be the one cobbling together all these different technologies in the hopes that it's engineered that can meet their challenge, and then also engineered in a way that can be scalable. It is our role to help with that ecosystem, which is exactly the core function of the IoT division at SAS. How do we work with those channel partners and ecosystems to build repeatable solutions and frameworks that can be leveraged? So I'll still go back and say, as long as a government entity has a clearly defined and articulated problem statement, I would encourage them to engage their partners that they work with and have a good relationship with, and use them as an extension into the broader ecosystem to start to solve and whiteboard and how you're going to solve that challenge. And then the last thing I would say is, please think about those future requirements, right? What you need today may not be what you need a year from now. And if you stand up a solution that is relatively rigid, you're just going to essentially have the same problem down the road. Look at it as a whiteboarding session. Look at it as a way to architect a solution that is fit for today's requirements, but also has this flexible, open-ended approach for future requirements.
Excellent. Awesome. Well, thank you. I hope that everyone today found this interview as insightful as I did. I really liked the use case examples that you used, and I was really fascinated about the digital twins concept that we were talking about, especially about how you talked about it trying to just be proactive more than reactive during those water flooding challenges, for example. So that was great insight. Be sure to stay tuned for our upcoming webinars, and also mark your calendars for our next conference in Austin. We'll have very important discussions such like these. And also just a reminder that our panel submissions are open, and they're open until July 26th. So submit your ideas so that you can have the chance to lead the conversation in the fall. We look forward to seeing you all there. And again, I want to thank Tyson from SAS for coming and doing this interview today with us.
Thank you, Michael, for having me, and I look forward to future work together.